Assalamualaikum and a very good day to you all. In this video, I would like to share with you about extremum problems, and I'm hoping at the end of this video, you should be able to find the stationary points of a given curve. So what is extremum? Extremum, it's came from the word extreme. Extreme. Extreme, it's like it means that too much or too little. Okay. So why extremum? Extremum is for singular. Singular. If it's a plural, then we call it extrema. Okay. So it's just some fancy terms. We are referring to them as critical points. Okay. Some question will use the word extremum. Some question will use critical points. But more or less they are the same thing. Okay. So what does it mean by extremum? What does it mean by stationary points? Is we can visualize it like this. Okay, like the blue curve over there. Let's say we have y equals fx as the blue curve, and then at a certain point we have 3 critical number. Okay, so we have a critical number that has a green color over there, and then red color over here, and another red color over here. Okay, at the green color, at the green star over there, the dy dx does not exist. Okay, why is that so? Because the nature of the shape doesn't obey with it doesn't differentiable. Okay, that is why the dy dx or the gradient function does not exist, because it is not differentiable at this point. Okay, maybe this point is negative kan, maybe it's -1 lah. So this one it means that at x -1 it is not differentiable, while at this point and at this point it is differentiable. Therefore, at these two places, at these two critical number, the gradient is 0. Okay, why the gradient is 0? So maybe we can zoom in. I zoom in at this one first. Why the gradient is 0? Simple, because first thing first is flat lah. So if it's flat like this, so clearly the gradient is 0, the m is 0. Now let's look the area between here, the left part of the curve. Okay, so if we take a point over here, and then we take a line tangent to the curve, what we can see, this gradient is going up from left to right. So it means that the dy dx or the gradient is greater than 0. Okay, and then if we look over here, somewhere here, the curve on the right hand side of this point. Okay, now and then let's say I take this point, and then I take a line that tangent to this curve, blue curve. So what we can see at the green line, this green line from right to left is going down. Okay, so therefore the dy dx or the gradient is less than 0. So as you can see here, if the gradient is different, okay, from left to on the left it's positive, and from the right on the right it's negative, it's different, right? Therefore the point in the middle is a critical point. use different color lah. If I use red also. So this one we call critical number. Okay, number why? Because it's a value of x. Okay, if it's a point, we refer at this place as a point, then this is what we call critical point. Later I show you what's the difference. Tak apalah, we treat them as a critical point. Okay, so over here you see, okay, it's a critical point because the dy dx, the gradient, is equal to 0. So how about this one? Okay, the situation is more or less the same. It's just that they are another way around. So on the left hand side of the point, okay, the dy dx or the gradient is less than 0. Okay, at first they have negative gradient and then they going flat like this. Okay, like the red line over there. This one dy dx, since it's flat, equals the gradient equals 0. And then after the gradient becomes 0, the gradient becomes positive, which is greater than 0. Okay, so this is also our another critical point. Okay, so there are in this experiment problem, there are two kinds of critical point, whereby the point has a negative gradient, positive gradient on the left hand side and negative gradient on the right hand side, or the point has negative gradient on the left hand side or an positive gradient on the right hand side. Okay, so this one, what we call, if this is the case, then this point we call it as local maximum. Okay, and while this one, if this is the case, then this is what we call local minimum. Okay, so don't worry so much about the local part. So what we are focusing is whether it's a maximum or minimum. That's all. Okay, so let's differentiate. What does it mean? What's the difference between critical number, critical value, and a critical point? Okay, so when we have fx, okay, equals whatever, when we take the differentiation, the prime, and then we let the f prime equals 0, okay, and then we solve for x, okay, so the x that we get is what we call a critical number. Okay, and then if we take the x, okay, if we take the x and then we put inside the original function, okay, we put the c, since the x equals c, right? So we put inside the original function. So the fc, or the value lah over here, is what we call critical value. Okay, and then the combination of both numbers, both values, is what we call critical point. Okay, that is why we write it something like this. Okay, so I think that's all the term. So please don't exchange them willy-nilly. So maybe we try one or two examples. So wait, how many? Okay, the one first derivative test I share in another video. Okay, now what's this? Critical point. Okay, so we have this fx. So dy dx is 3x squared minus 3. Okay, so we let the dy dx equals 0 to find the x. So what we have is 3x squared minus 3 equals 0. Squared, I'm sorry. So what we have is, we solve them, we get this one, right? Oh, nice. And then we have two values. Okay, x plus 1, x minus 1. So therefore, we have x minus 1 or x equals 1. Okay, and then these are critical number. Okay, remember the x here is a critical number. Now, the question wants critical points. So we have to find the y. Critical number, what is the y? Y is the original one. So y when x minus 1, okay, when x is minus 1, y equals x cubed minus 3x. X cubed minus 3x plus 2. Plus 2. Okay, so I just plug in minus 1 inside here. Okay, and then that's minus 1 plus 3 plus 2. So berapa ni? 4. 4. So minus 1, 4. Okay, now another when x is 1. So y equals 1 cubed minus 3 1 plus 2. So we have 1 minus 3 plus 2. 0 Oh, 0. So the second one is 1. Why doesn't... Okay. 1, 0. So therefore, critical points are minus 1, 4 and 1, 0. Okay. Thank you for your time and attention. Assalamualaikum. Have a good day.